Remember how when we implemented authentication, we said that just hardcoding the credentials is horrible and we need to change that. And then we kind of forgot about it. Well, I didn't, so let's fix that. What we need to do is to store the users in the database. For every user we'll need the name and the password. But storing passwords in plain text is a big security no-no. Main reason is that if the database is compromised, we don't want to put some of our users at risk. And I'm talking about people that use the same password for everything, so basically everyone. That means we have to be smarter. Instead of storing passwords, let's store their hashes and salts. If you're wondering what the hell is a salt, we're not in a kitchen, here's a short explanation. Hashes are good because we don't store the original password, they're kinda hard to calculate, and hashes are almost impossible to revert to original password. But here is the thing. If you have a lot of free time, you can collect all the popular passwords and create what's called a rainbow table. A rainbow table is a pre-computed table or a dictionary of passwords and their hashes. So if you are a big bad hacker and you stole our database, you can use a rainbow table to get at least some popular passwords for some users. But let's say we're smarter and here's what we do. When we create a new user, we generate a random string called salt. And then we compute a hash of password plus salt and store the result. Now you can have all the rainbow tables in the world. I bet you don't have hashes for a password with this exact salt. And on login attempt, we get the user data from the database, calculate hash from password and the salt from the database, and compare it to the hash from the database. Okay, let's fix the model, create a new migration and apply it. Now we can update the login function. First, we get the user with the provided username. Then we use the provided password and the stored salt to calculate the hash. We'll use the crypto library that's built in Node. It has an script function that is one of the many good options to do what we need. It doesn't have a sync variant, but we can always promissify it. It returns a buffer, so we convert it into a hex string and compare it to the saved hash. If we have a match, we're good, just send a token. If a user does not exist or hashes don't match, throw an error. Sadly, now we cannot log in into our API, since we don't have any users in the database. Let's add one by hand for now. I found this online hash generator, so we can generate a random salt by hand and get the hash. Now put it in the database. Perfect, looks like it's working. The next step is to make a way to manage the users, so let's create a new controller with the usual endpoints. We'll start by making the DTOs. Don't forget about validation decorators. I'll also write a short function for hashing passwords. We'll be using it in create and update endpoints. All we do here is we create a random salt and then generate the hash from the password and the salt. Now I'll write an endpoint to get all users. An endpoint to get a single user, an endpoint to create a user, and finally an endpoint to update a user. Remember that in Prisma update function, if we pass an undefined as data, that means we don't want to change the field at all. Let's test it. By the way, I created a collection in Thunder Client where I add all our endpoints for more organized testing. I don't see any bugs, so let's switch to the admin project. First, we need a new page and a table for users. We've done it 100 times already, so let's go. Create a new API method, a new query, and a domain interface. Then make a table component with only one column for now. Make a new page for the table, and add a link to the new page to the taskbar and add a new route. The next step is to create a new user form. Again, we need a new API method and a mutation. Then I'll create a form component with only two fields for username and password. We probably should use a different input type for a password, and maybe have a confirm password field. I'll think about it later. The new form needs a new page, a route, and a link to it from the users page. Here's the problem though. We can only access this page and the API endpoint if we're already logged in. But what if we just installed the app and we have no users in the database? That would mean we're locked out and can't do anything. To fix it, I want to check if there is no users yet. If there is none, I'll allow it to create the first user without logging in. For that, we need a new endpoint to check if there are any users. We can't just allow an authorized user to get users info or even their count. So the new endpoint will just return true or false. And we'll make another endpoint to create the first user. It's not gonna be protected, and we need to check if it's really the first user. In the admin project, we need new API methods and queries for the new endpoint. Don't forget to invalidate any user's query on mutations as well. Then I'll make a new form for the first user. The form is gonna be almost identical to the new user form. Yeah, I know what you're thinking. This is horrible to have that much of copy-pasting. But relax, we'll get to refactoring and code quality pretty soon. Then we need a new page for the form. Here I will check and redirect to login page if there already are users on the server. I also want to do a similar check on the login page. Don't forget a new route. So now, if I reset the database and try to access admin panel, I'll be greeted with the new user form. Here I can create a new user and use the credentials to log in. There is one thing that's kinda annoying though. Every time I reload the page, I need to relog in. This can be fixed by saving our token in local storage and loading it on page load. And we also need to check if it's set on login page and redirect to the main page if it is. To be honest, I don't really like what's going on here right now with all the redirects. I mean, it works, but I think later I'm gonna need to figure out a more elegant way to do this. But there is something I want to do right now. If you look closer, you'll see that local storage logic only cares about one thing, but it's kinda smudged across the whole component. This is actually a good example to show how convenient custom hooks may be. Let's create one. Our new hook is gonna have a state variable, a useEffect hook to load the token from the local storage, and the setOfToken function that updates local storage. Note that right now the return type is the array of strings or functions. If we want this to be more precise, meaning that it returns an array of two elements, where the first one is a string and the second one is a function, we can just mark the result array as const. Now our provider looks much cleaner. Okay, I think that's it for today. I hope you enjoyed the video, and I'll see you in the next one.